All right. The magic live red button is on. All right. Welcome, everybody, to the Data Center News Show. I am Amy Palvido. I am your host, and I got my friends in the house. Sean's a new friend. We're welcome. We're going to talk all things data centers. But before we get started, I will let my guests introduce themselves. And Gino is back. Hey, Gino.
Hey, Amy, thank you for having me back. So, Ginés Toromazote with Excite Group back on your show. Thank you.
Yes. And Excite's a data center developer, right?
Yes. Data center construction, engineering, procurement, and construction company. So design, build primarily, but we can interject and meet customers wherever they are in their journey.
Very cool. And Mr. Sean, welcome.
Sean Farney, thank you so much. First timer here.
You are first timer
and caller. So glad to join. I'm a little bit out of words because we've been talking all week at conferences and whatnot about construction and getting it done. Hopefully I can add something. I've been with JLL for about 3 years and kind of at the strategy level help all our different businesses, site selection, construction management, commissioning, FM, ESG, AI, advisory, all that type of thing. So look forward to having some fun talking data centers. Yeah.
Yes, exactly. Yeah, exactly. Well, GTC is on everybody's brain. I was texting. So Jay Hussey, who's with H5, is usually on the show, and he's at GTC. So he's like, Amy, I can't come on the show. And he's there with like 80,000 of his closest friends. Apparently, there's like 80,000 people at GTC. But have you been to this? Have y'all ever been to GTC? NVIDIA's big.
I have not. No.
You have not. Oh, okay.
Right. Not the big one. No. It was a and those big ones are, it's like going to an Amazon or Microsoft mega conference. They're fun. It's just it can be a tough experience. There's just so much mass, right? But it was pretty interesting. In parallel, working hard, talking about data center construction and having this going on and new headlines dropping.
I know.
Around what Jensen and NVIDIA are doing, it's brilliant. I mean, they own the market and they're creating, they own it and they're creating the market because it's a bit of a monopoly. And to come out and say, day one, we need 100-fold increase in, for these next AI epochs. I mean, that's really good for them in the market. But to be hearing that and then talking about how to build them and how to continually, chase and change the basis of design now, which is in lockstep with processor road mappings. It's just very, very interesting. And that's starting to be the magic matching design build with, which we used to do to match a basis of design that hadn't changed much in 20 years. And now it changes every time there's a NVIDIA conference, right? So that's
yes. Yeah, they were. It was amazing because I listened to his keynote, and he was going through a lot of things. They were talking about automotive, but they were talking about the chips and what they were building and the different generations of it. But what hit me was the weights of the systems and how heavy they're getting, right? And they're like 3,000 pounds, a ton and a half for like these things that they're trying to build, these racks. Or I was like, shut up, 3,000 pounds? Like, oh my gosh, the engineering you're going to have to do on foundations and the steel that's going to have to go into these suckers, and just in order to support the weight of them. It just amazes me. I don't know. I mean, is that normal? They all weigh a ton and a half? They're like just heavy?
Yeah, no, that's completely abnormal and definitely stepping into new territories there. I'm certain that there are some busy structural engineers out there trying to figure it out.
Yes.
So, I mean, it is a challenge, right? I mean, anytime you have breaking technology hit the general availability, there's always a big challenge ahead, right?
Mhm.
And and I'm just curious to see how everything is going to unfold, right? Because there's only so much that is actually commercially available, and not commercially available for the consumption of the chipsets themselves, but to support it, right? So,
Right.
how many cooling systems, from an MEP perspective, are going
Mhm.
to be able to support a monster like that? Where I
Right.
think we're talking 1.1 megawatts a rack. Well, which is we were talking about this yesterday, Sean. Is essentially two racks, but still 1.1 megawatts. I mean, we used to build data centers around. I mean,
Kilowatt.
not 10 years ago, there were 5 megawatts, 5, 10 megawatts, and those were, pretty sizable enterprise grade type of buildings. And then we thought the oceans were going to boil at 20 megawatts. And then when it got to 50, everybody's like, oh my God, where are we going from here? And now we're talking gigawatts. So
I know.
is definitely a big challenge from multiple perspectives, but is just the availability of, like you were talking before we started the show, electricians.
Mhm.
Uh,
Yep.
I mean, just from the trades themselves, how are
Right.
you going to sustain this? And then we're not even talking about that. We're really stepping into uncharted territories, right? So
Mhm.
yes, this type of technology has been deployed at NASA or maybe in the military
Right.
under a lot of secrecy.
Yeah.
So
Mm.
these are things that are being made commercially available, and now we have to figure out how to divide the pie, if you will, right? And how we're gonna make the pie.
Yeah.
Um, yeah, so everything boils down to a recipe, to put it into food terms.
Yeah, it's a much different pie.
Yeah.
I had to deploy to 20 kW per cab for a go live date in 2009 for Satya Nadella when I was at Microsoft, and that was 20 kW per cab. Whoa! Like,
Yeah.
wow,
Mhm.
no way. We're never going to use that, and most people still haven't gotten to that. That
Mm.
wasn't that long ago, and to have this, and we were running along at like an average of 3 kW for forever, and then maybe 6.
Mhm.
And then we started to see things creep up several years ago. But the Chat GPT drop hockey stick with
Mhm.
densities just since November of 22, it's really it has just blown everything out of the water. So the
Yeah.
densities are weird, and it's I can still remember at the start of my career crawling around, migrating off of the mainframe to distributed, right? Like
Mhm.
interfacing mainframe, via ESCON, like mainframe interfacing with front end processors over to DEC alpha machines, and then token ring and off to these new things, these new Novell server things, like,
Right.
and it was such a big deal to distribute, and now we're re-densifying or centralizing into these massive racks, which are really just computers. So kind of seeing
Yep.
the same thing again in some ways, but then on top of that, and that's kind of within the walls of the data center. I think outside of the walls of the data center, I think we will see, because of this and because of where we're going with the move to inferencing, I think we'll see a distribution of sites, and not the N2 monolithic large hub sites, which are doing large language model work right now. But I think we'll see the
Right.
addition of edge sites, which is the reverse, which is doing a hub and spoke or distributed model. So it's crazy right now. There's so much going on all at once. I think
Yeah.
even more than this movement in the 90s from or to client server from centralized. So it's fun again.
Yeah. Yeah. I mean, it's the time to be in the data center industry. I mean, for sure. Right. And then one of the stories was talking about low levels of vacancy, and it's been low forever. Like every time I've been talking about data centers, it's always been like the vacancies at what, 2% or something like that. Is that even real?
2.6. Yeah, we ended up in North America at 2.6. That's
Yeah.
what JLL data says, which is
Yeah.
incredibly low, and it hasn't stopped. So we're actually seeing we will asymptotically approach zero for the next few years. Like it's wild.
Yeah, for sure. Because I mean, you just have that lag time between when you can build a new one. I mean, the supply that comes online is, slow coming. And so unless you're like Elon Musk and you're just going to go spend billions of dollars and just go get something online because, you've got FU money. So you're just going to go get something online.
Yeah, that's my enterprise clients. That's the challenge is they're competing against these bottomless pits of money in the Mag 7, and they're just grabbing everything because whether there's strategic issues of deciding whether if you're a hyperscaler you're going to build or buy or both, or you want to build your own and are trying to do it, but you just can't do it fast enough, so you're going to go and grab all the colo space. So it's really becoming the haves or have-nots, and enterprises for the first time. And this is the strategic issue that's really a problem for business growth. I think for the first time, enterprises face the prospect of no capacity, colocation capacity over the next 5 years, and that would limit their business growth. Now that you need compute to grow, it's pretty much for every company. So that's a new keep you up at night worry for enterprise CIOs right now. Like, geez, I need this capacity and I can't find it because there's only 100 kW chunks left all over the place, and they're up 37% year over year because of this decline in availability.
Yeah, that's totally, and that's all driven by their transformation into AI and becoming AI enabled and all the whatever you want to call it. Is that right, or is it they're just storing more and more data? And
it's both. So the
storage.
So like there's the societal trend, and if you have kids, you know this. Like they don't delete anything. And every generation creates more and more data. It's like this, and it's not stopping because streaming and Snapchat and Instagram and all these other things that we don't even know about. So every new generation incrementally creates more data as they come into this world, at least in the first world. So that's a contextual and cultural trend that's not changing. It's like 323 million petabytes a day created or something. Just it's a wild number. It keeps going up. So you got that going for you, which is nice. That gives you your normal hyperscale. What we've seen over the past few years, like 20% CAGR.
Yeah.
And then throw AI on top as a new force. Suddenly, if you're a Fortune 2000 company, you better have AI in your products, or else your competitors are going to drive you out of business. So you need this capability. You might not be able to find colo capacity. It's really expensive, and there's some technical limitations, particularly around latency, if you want to try to do inferencing with cloud. So you may have to figure out how you're going to provision that yourself. So there's the normal forces, and then this new AI thing, which has been the black swan for the last 2 years. Pretty incredible.
Yeah. Some of what Jensen was talking about was this, obviously the move to agentic AI. I mean, we had the LLMs, and the LLMs are there, and that was just like one version, the initial version. But now we're moving to agentic, and then then the AI is actually going to learn from itself. I mean, that's where they were thinking like the latest versions of Open and Llama and all the other ones like 4.0 is where they'll start doing these simulations. So they're going to need the data centers to just run the simulation so the AI can learn, right? It's going to need that compute to have on, and they'll run. That's why Waymo has been able to do what it does, because it's learning on its own, running simulations. And it's doing one of the NVIDIA, there's like 2 different solutions that NVIDIA has. And then one of them is just to let's make you give you different variations of what you have to do so you learn how to do your task, which is it was kind of interesting. But yeah, I can't imagine where we end up having to go, in a year, where we're going to end up being in a year from so I don't know. Do y'all know how many data centers are actively under construction at the moment? Is there anything out there keeping track of that?
I don't track number of facilities. I can say at the end of 2024, 6.6 gigawatts, and that's just US under construction.
Yeah.
That's a lot. And from a market's perspective, from a percentage look at things, Salt Lake City and Phoenix are the 2 largest percentage gainers in the US. As far as overall size, Nova is number 1 by far, but power constraints in Nova and generally everywhere have started to push new frontier markets. Push load from Nova to Columbus and Atlanta back to Chicago, and then the super frontier markets like Fort Wayne, Indiana, or anywhere in Louisiana and Alabama, where there used to be. We ran for many years from all the coastal locations, and
exactly.
Now it's kind of wherever you can find energy.
Yeah,
That's
for sure.
Where we're going.
That's interesting. So one of the other news stories that came out of GTC was that NVIDIA is partnering with a lot of different people. They said that they're partnering with Cadence, they're partnering with Schneider Electric around digital twins for data centers. And I was like, well, welcome to the party, man. I already do this. This is what I do. Thanks. Okay, I'll help you out there. It's pretty funny. But have you seen any digital twins or in construction or even in on the operation side really deployed yet? Have y'all seen any of that or no?
What about you, Gino?
Yeah, from a construction perspective, that's something that we implement in all our projects, right? But I think what they're referring to is after the go live,
right?
And that that's not something I track or I look into, to be honest with you. So I'm not familiar with that territory. Maybe Sean, you're more familiar with that.
Not with the recent announcement that was 2 days ago. I will read up more on this. So JLL internally uses some digital twinning technology to train our ops folks. We just have to. It's just easier. We got a few thousand data center techs. I've heard all the construction folks talking about it. I don't have any experience with it. If Schneider's investing in it, they're a leader, right? I trust what they're doing. They must see a need for it. So I will. I'll download the PDF. That was a new one.
I know. Yeah, Cadence already kind of does it on an operational side, but it's limited. I don't think they're in a lot of different places. I mean, what we're building is really, the ability to, you're 3D modeling and you have the ability to see in real time what's happening on the buildings, right? But couple of cool use cases we're seeing is the handoff, like post-construction handoff to operations. And there's a little bit of like data loss there, right? Here you go. Here's all your stuff. Have fun, right? And then the operations teams have to come pick up. So there's a use case there for sure, right? And then just making sure that, there's not going like this on who's supposed to pick it up, operations or construction during the warranty periods or whatever it might be. So there's a little bit of a use case there, but honestly, it's really on the operations side. It's just optimizing your building, right? And understanding your building systems. And things like that. Most digital twins aren't looking at the servers per se, or ours isn't, but it's just looking at the building operations, the building systems, and are those optimized? And can you do incident response faster? Can you, because you've got your energy monitoring systems and you've got your DCIM and you've got your CMMS, right? Can we integrate those together, visually represent something, and actually, make something, more insightful? I think that's what folks are trying. Well, that's what we're trying to do anyway. But I think that's what folks are trying to do. So
I could see a huge need for this as a strategic tool from a city perspective. And the context of that is with these chip densities going up, with everyone hybridizing, but still not knowing exactly where we're going to be in a year or two. If there is and we're building sometimes on a hope and a prayer for the first time in decade, like we're really knowing where we're going with this, but we know we got to support, this week we got to support 60 kW cabs, and then we know next year it's 80, and then megawatt, whatever it is. So a long term, transition from commissioning, integrated system testing, handoff from build to ops and run, and all the while having a tool in the background which could then, based on how you move your power around over a 3 or 5 year period to support these denser and denser cabinets, showing you the impact of that across the entire facility, one lines, redundancy, and then even MEP, because the cooling is getting crazy with how we have to move water around now for liquid. So that, again, Schneider's pretty smart. They have good insights. I would guess that's the path that's what I would.
Yeah, probably. For
I
sure.
mean, even co-location operators kind of got smart early on and started adopting similar strategies to be able to, complement the DCIM systems and MMS systems to be able to prevent incidents from happening. So both organizations that I've worked at, both RMON and H5, I know they've implemented digital twinning in order to be able to prevent foreseeable gaps in operations. I think from a clean modeling perspective, whether it's 3.0, 4.0, or beyond, there's a lot of visibility that you can gain. And, it's from a training purposes, even for an oncoming operational team, is very useful, right? So that is, but then again, it's very sensitive material, hard to, got to keep track of where you store that information and who has access to it. And so there's a lot of sensitivities that are built around that. And then it depends on the contractual model as well. What are the statutes of limitation? And I think there are other complexities that just, putting the software packet together to be able to, kind of translate from a constructability perspective over to a operability. But it is something that I know we exercise on the commission side at Excite. I know that we exercise this in the constructability aspect of projects. We've been doing this for a very long time with chip fabs already.
Right.
But this is more of a design build type of model. Traditionally, the data centers market in North America has been more of a design bid build. So it makes it a little bit more complicated from a contractual perspective to kind of have the visibility necessary to be able to predict sort of these gaps in operability that can surface in the future, whether they're structural or operational. It's a matter of just understanding how that information that data can be managed and secured, and then transferring in a manner that is responsible for all parties involved.
Yeah, makes sense. It's an interesting time. So one of the other stories too, and that's really cool. One of the other stories was talking about scale, and obviously everybody's growing. Like they got green financing, but the article says they didn't say who got their green financing from, which is okay, fine. But what I've gleaned from that article is talking about their total capacity right now is like 4 gigawatts, and they're going to double that. Like in the next couple of years, they're going to add another 6 gigawatts of capacity to their portfolio. So somebody going from 4 to like now to 10, what does that look like from an operational standpoint? And like, do they? I mean, is that feasible? Isn't that what everybody's chasing? They're like trying to double the size of their portfolios. Like, what does that entail?
Well, it's good for outsource and outtask data center ops providers like JLL. We're growing like crazy because no one can find talent fast. And right now we're all still fighting over the same talent. They just rotate around through us and CB, and then all the hyperscalers always hire them away, and then they come back at some point in time and they do this and that. We haven't solved the problem on the front end of the funnel, which is recruiting early.
Right.
We haven't made it a sexy enough career on the MEP and critical environment support side yet for vocational school, out of high school, junior college types who are mechanically and electrically inclined.
Mm-hmm.
That's where we need to solve it to increase the size of the funnel of folks coming in. I think we wouldn't make the unions happy, but there could probably be some success recruiting directly.
Right.
We could partner with the unions doing that because we keep the industry keeps a ton of union trades. They're the best employed. But those are the perfect type of folks to come into the field. And currently there's a lot of conversion of folks who do general facility management to data center. That's not a tough thing to do. We've got some internal training to do that. Yeah, you're going to double. You're not going to Stack's really good. Like you're not going to, reduce your overhead by huge numbers. Like you're already really, really efficient. AI is not going to help that. We'll continue to automate. But you're going to need some people. And so if you're going to do that, if you're going to double in a few years, like you better start directly recruiting and even maybe setting up an internal training program to train these people yourself. Right. Or you just throw up your hands and you call us and we can help with that. But we're doing the same. We're hustling on the back end to do the same thing. We're moving people over from CRE FM. We're partnering with groups like Nomad Futurist and iMasons and others to again try to find this talent and get them interested and show how awesome this industry is, what a great career it is, how well it pays.
Right.
And it's in the headlines now, right? It's cool.
Yeah, it's cool.
My kids never thought data centers were cool growing up, and now they're cool. So that's a big rock right now for the entire industry.
So you're butting up against, especially on the FM side, on the facility side. I mean, there's labor shortages everywhere in construction, right? And then we have the immigration thing happening, which doesn't help. And then I mean, so I wouldn't assume that the data center or the facilities guys and data centers necessarily would be, folks that you would pull from general construction, or are they? I mean,
sometimes. Well, mechanical and electrical. Go ahead, Gino. Sorry.
No. So this is a challenge that we're faced with daily, and very often, especially in our space. We're very strong believers in upskilling. Mm-hmm. So it is really difficult for us to find the right human resource to upskill, and that is the challenge. It is doable. It is very much doable. But when we're speaking about data centers, Sean, we're talking about electrical, mechanical. You're talking about structural. You're talking about networking. You're talking about IT infrastructure. You're talking about software. You're talking about fiber optic cabling, and just trades that are very highly specialized, right? So how do you bring that all together, right? How do you make that sexy? And then that is more challenging now than ever before. I mean, it's part of the sexiness, but then again, it's part of the challenge that we have, an ever-changing environment, right? So we had to figure things out. But you're trying to position people that like things that are predictable and that are exact in engineering wise, right? And they want to fit everything in a box, and it has to fit perfectly, or else they don't want to know anything about it because there's no interest, right?
Yeah.
So it's very sexy to be at your forefront of technology, but then at the same time, how do you get those people that are going to find, what is imperfect in perfection? Just to give an example. So that is really the challenge. But for us, is what we found is that, like Sean mentioned, really teaming up with those organizations that are out there constantly trying to educate the public and upskill the existing workforce to get into a level where they can, exercise in this types of environment. But it is available. It is challenging, and that could be we can talk about this for days. I'm certain, right?
So when do we have an HVAC robot that's fixing mechanical systems? Have y'all seen any robots yet fixing stuff?
So I have not, but what we do understand, and this is generally available, is that a lot of the hyperscales are utilizing AI in order to write code at a very advanced, mature level for any software engineer, right? So that type of automation is there. Is it proven? Is there enough data for us to validate and to test to say, hey, this is something that we can rely on and depend on? I don't know. We will get there. I think eventually that's where the world is going. Absolutely. So I'll be honest with you. There's one thing that is certain. Nobody knows in their industry or anybody out there knows what's going to happen. That's
very true.
The only certainty that we can speak about. But it's fun. I mean, to me, this is fun. I mean, I love solving problems. I love getting down and dirty personally. I'm certainly that Sean probably advises his clients in a similar fashion, where he's seeing the ups and downs of this industry that have been quite interesting, especially in the last 3 years, where I remember doing a project where we're talking about, oh my God, we're gonna do 100 kilowatt racks, and we're lucky if we get into 60 kilowatts, and then we'll start testing that barrier or what have you, and now that's just almost like a thing of the past, and it's only been like 3 years, right? So I mean, it's also, you got to understand that it's not only are we innovating more, but now we're going to be innovating faster.
Right.
So that is the other monkey on that monkey wrench that you got to throw into this whole equation. So to me, is the smart operators out there are saying, okay, there's a lot of glimmer and shininess out there. Let's really talk about a plan that is executable. Let's talk about what is commercially available. Let's talk about how we are actually going to achieve our goals, and how we're not gonna get caught, in the middle of all this we could have, should have, but didn't type of conversation. So you see some organizations that are very well at executing on the plans, and have engaged with consultants like Sean or companies like ourselves very early on to make sure that you have a solid plan in place. And I think that's That's paramount in this environment of uncertainty. But that goes back to how do you actually execute? The only way you can execute because the talent is not available is by upscaling the existing workforce.
Have you seen a HVAC robot, Sean? Have you seen one?
No, I haven't. I've been watching. I was watching something this morning. They're getting pretty scary.
They're doing pretty cool things.
The next 10 years are going to be really, really interesting. And then
Mm-hmm.
once they combine, there's a really cool Bruce Willis movie from more than 10 years ago called Surrogates, where robots get kind of melded with, I would say, kind of social media, or it's Avatar-esque.
Yeah.
And I think we will get there. That's going to be a weird world, but I don't think we're going to see robots wrenching for a bit. We all know that human error is about 80% of data center outages, right? So you'd think, well, a robot would eliminate that. If the coding of the robot and how the robot process mops was free from humans completely, I would agree with you. There's still a lot of nuance. Not to be a Luddite, but there's still a lot of human nuance required in rounds and readings.
Mm-hmm.
And I think there would be a lot of resistance from some of the different labor forces and groups and affiliations involved in providing labor on the floor to data centers. Google for many, many years, what Joe has been doing there with using AI to do operations better is
Mm-hmm.
they've done amazing things. I think that will continue. I think we will do things like use advanced AI models to process millions of pieces of gear and all their performance metrics and numbers to help us do set points better based on humidity and time of year and location and geography and all this stuff. I think there's still a lot of untapped crunching we can do to run our data centers better. But the data center wrenching on the floor, we will get there, I would think, particularly if we have more smaller, lights out, edgy AI inferencing data centers that are homogeneous with their gear and smaller. That may be the mobile force that is used to maintain them lights out. But it would be a super cool gimmick. It'd be great for one of these big conferences to put the robot with all of the mops in its head up on stage to show,
Everything that can,
they would have like it'd be super fake, but it'd be fun to see like this cool video of a robot with a built-in tablet and like tapping away and doing rounds and readings and moving on and ordering consumables and doing work. And if you can have like two robots doing lockout tagout stuff, like
hey, there you go.
you can really have like fun with it. Who knows? So sure, we all know the rate of tech advancement. Like, so we'd be remiss if we didn't say yes, we will get there.
Yeah.
I don't look out more than a year and a half anymore in this industry, so I don't think it'll be the next year and a half.
Okay, good to know. All right. 18 months, that's all you're giving us? All right, okay, I got you.
That's it. Yeah, I can't
I mean, it is moving super fast. Can you imagine? I mean, like, it seems like OpenAI came out 100 years ago and it's only been 3 years. So, it's crazy what's been happening. And then DeepSeek on top of that, and it's just accelerating and it's changing. A friend of mine actually has a intelligence model. It's called Applied General Intelligence. Mm-hmm. And he's a startup founder here in Austin, and they've been working through their model and they're in the middle of testing it now, but it doesn't use nearly as much power as what OpenAI and all of those guys use. It's actually really cool. And he's, and it's starting to get, it's a reasoning model like Jensen Huang kept talking about yesterday, where one was on statistics and one's like a reasoning model. His is actually a reasoning model, and it started there. And so it can talk to itself and judge its own answers and do all these different things. That's what his model does, which is super cool. So yes, I don't know where we're gonna like. He's probably gonna blow up soon, and like it's gonna be interesting world for us for sure. Interstellar, it's coming. We're gonna be interstellar. We're gonna be in space, doing time travel or whatever. I don't know.
I have faith in coders to write more and more bloated and dense code. So it doesn't matter how efficient we get with how we can process. We will always write to support much larger processing. But that's a good thing. That's a Jevons paradox thing. That means the use is widespread. It increases. We need capabilities at the low, middle, and high and spectrum, and we will invent new ways to need ridiculously, the 1 kilowatt up to much higher cores, doing all kinds of crazy stuff we don't even know about yet. Maybe we'll figure out weather someday. I don't know.
Maybe. Who knows? All right, let's talk a little bit of 2 more topics. And one is about this liquid cooling thing. So I talk to data center managers every once in a while. And this whole liquid cooling thing is freaking some of them out because they leak. And so they're like concerned because if you have, and I didn't realize, I didn't understand this, but this is how they explained to me. And one of them was explaining it to me this way. It's like, you have like 100 GPUs on a thing. And if one of those suckers leaks, it's not like you just go and change that one out, right? You have to swap out the whole thing. And that was his understanding. That's what he was explaining it to me. And so that's the biggest concern, is this, because all they were talking about yesterday or the last couple of days in NVIDIA is like, everything's going to be liquid cooled. Liquid cool is the bomb. It's awesome. We're going to liquid cool everything. And then I'm like talking to these data center managers, like the suckers leak, man. And it like ruins everything. So anyway, are y'all hearing anything about liquid cooling concerns?
So So actually, Sean and my boss were on a panel about this yesterday at a conference.
Was that only yesterday? Was that really yesterday?
Oh my God!
Was yesterday?
Holy smokes!
It was yesterday. Yesterday morning at 7:30, 6:30 Pacific.
It took me like 12 hours to get home. We actually had to go to a different airport. O'Hare was shut down yesterday. So anyway, that seems like a week ago. But
yeah. Well, so one thing that we didn't talk about is forget the implications of potential failure because of leakage, right? I mean, that's a foreseeable risk, right?
Okay.
Let's talk about the cost, the actual cost, not only to implement and not only to upgrade an environment or what have you, but the other risks associated with it, right? So now you're bringing in something else into the equation that could go wrong when you already have 50 things you're worried about, right? So let's just talk about.
Let's just throw some more in there.
You're adding more risk to the equation. My job, I think, at this company is to de-risk the operation and improve the revenue mix, right? I would get fired like tomorrow if I were to, make this type of suggestion. So I understand where the data center operators that you're speaking with have their concerns, because it's a real concern. Now, that is where, that's why there are boards and there are executives out there that get compensated quite well in order to make these hard decisions, right? So you have to really quick. Do we let the competition take us over because we're not doing enough?
No.
Or do we, upgrade what we have and do the best that we can with what we have? Or do we maybe risk a little less by bringing something else that could be dangerous to my environment and maybe go explore one of these new neo AI clouds that are emerging everywhere that potentially could help alleviate those pains? I don't know. Those are the questions that customers are, wrestling with at the moment, and it really comes down to, commercial availability or viability for that matter. I mean, is it really feasible for us to go through this whole exercise and maybe end up with a broken operation?
Yeah.
Do we have enough trust? You can have all kinds of, you know, clauses in your contract, to try to prevent any damages. But at the end of the day, do you even want the damages to actually occur, right? I mean, so you're already kind of, even on a contract negotiation, you kind of see where this is going. You kind of see, some of the things that are not as so apparent, but are really the things that are being weighed into this type of decision. So, for some, I'm sorry, for some organizations, they find themselves where they have to take the risk, right? This is something that they cannot avoid, right? So they're going to have to make do with what they have, and they're going to have to deal with it, right? And this is that's just how life is. I mean, it comes at you, it doesn't ask permission, and it doesn't wait, and you have to make these decisions, right? So these are tough decisions that need to be made, and the more time that you have to consider and think, the better off you are. But sometimes even the business itself does not allow the time necessary to make the right decision. So, so I can see the concern from a data center operability perspective, but then again, it might just be their job. I don't know.
It's like, suck it up and get over it.
I mean, what do you say? I mean, what are you seeing, Sean? I mean, you guys operate a lot of sites, and you probably have a lot of customers in this situation. Yeah.
I to prepare for this panel yesterday, I spent a bit of time. It's the best part of my job. I do a panel on some part of the tech, and then I can go talk to other folks who are doing it to keep learning. And I hadn't done a super deep dive on liquid cooling. So for the last few weeks, I got to talk to all of my data center managers and techs who are currently hosting pretty large critical load in liquid, and it's fascinating. So we resisted it forever. Once we got the water off the floor in the 80s and 90s from the mainframes, we never wanted to come back, but now it's back with a vengeance. But there's still a bit of resistance because, data center managers are bonused on uptime. At least I was, and complexity creates more entropy, and the management of entropy is what data center operations is, right? And so the more stuff you put in the mix, the harder it gets, and the greater your chance of failure is. And so liquid is another thing; it's another variable, and there's a rethinking. So the cool part of liquid is the ability to leverage your 20-plus-year-old chiller plant. Like, you can hot tap your chiller. You're like, hey, it's in most, especially now in commercial real estate, occupancy is not quite what it was when you designed the headquarters 20 years ago and bought the 2 million square feet, and now you got 100 people coming in every day. So you have spare capacity in your chiller plant. It's another 20-year plus asset. You can tap into it. You can use that chilled water loop and even your thermal storage to off gas or exhaust this heat. That's really cool. But there are new things that this brings to the floor, like needing to completely change how you do redundancy and resiliency, for example. So with a room full of air, you have a little bit of time. If you have an outage and your cooling goes out with a room full of air, you have a little bit of time before you start melting equipment. Not the case with liquid. Like, if your liquid stops, you will boil it and you will melt chips like right away. So this is a new thing. So now you need more pumps to keep that water moving. Even if the chilled part of your chilled water plant is not working, you need these pumps on UPS backup. Like, we never had water on UPS. Like, so there's some different pieces and parts here. There is you need leak detection, like in all kinds of different places that we never thought about. The the quality, the veracity of the water now makes a huge difference. So Nalco and Ecolab, those folks are really excited because they're relevant again. Like water's cool again, so to speak, no pun. Like, wow, we got to do all these new things. So we've added this massive amount of new knowledge to the body of data center management vis-a-vis water, or I should say water, liquid, that we kind of sort of know, and it bridges like electrical and mechanical, like that's starting to come together. And it extends out the point. It used to be like, critical environments would maintain up to the RPP, and then everything else was IT. Well, now if you've got liquid going right to the rack or to the chip, or depending on how you're doing it, like now there's a new place to draw the line, and what does IT do, and what does facilities do, and so there's all this new stuff. And takeaway, it's just different. It's good for us because there wasn't a lot of different for a couple of decades, I think. So it's good for us. Learning is good. Change is good. Only those who don't change will not evolve. So it's an exciting time in the industry, but it complicates the labor shortage because there's new stuff to train on and do
and learn. Just like just when you needed something else to do.
Right.
You didn't have enough to do, Sean.
Not at all. No way. So they're the smart ops people, and ops people they're born pessimists, and that's why they're good. But they'll complain about it all, but they love new stuff to tinker with and poke and like pull levers, and we're gonna try this, and so we haven't even gotten to the let's let the big brains play with this and optimize it. Like we haven't gotten to that stuff yet. In the next couple of years. So I think there's some hope around making that stuff do better. And once it's adopted, everyone's familiar with it, then we can really start pushing the envelope and doing some creative destruction with liquid cooling. We're way before that phase yet.
So is air the redundancy for the liquid cooling right now? I mean, are they using air as the backup plan, or is it not, is it all did they take anything away? Or are you just adding something more to the mix, and then or is it still in flux?
You're gonna need air for network and some other equipment. The only place you could even conceivably do 100% liquid would be a total greenfield, very special purpose build. There's not many of those. It is happening, but when you hear that, liquid cooling will drop your OpEx and embodied carbon by 40% because you're getting rid of all the HVAC and crays and craws. And I mean, in theory, I don't know if anyone's quite doing that yet. I don't know if Gino, you're seeing things differently.
You know what? Maybe this is a shameful commercial for a company that I'm very happy, very familiar with, and very fond of. This guy's actually disproved Moore's law many years ago, and they're a DARPA-funded project that actually relocated from Virginia to Arizona to show that you could get a 60% delta T with just ambient air, even if it's just 120-degree good Arizona summer air.
Look at that.
Yeah, so so that is Force Physics is the name of the organization, and they've been kicking around tires with hyperscalers and some of the more prominent OEMs to kind of get this scaled. The problem is that they can't scale. To be able to scale this type of operation, especially with the workloads that we're seeing today, is almost impossible without an OEM partner in the middle, right? But they have proven that you can actually attain a reduction in heat, a heat exchange of 60% efficiency, which is almost unheard of. I mean, I think water is maybe 51 or 52 with just ambient air, which could potentially be, more viable as a disaster recovery type of mechanism. And I really don't know. I'm not an engineer. I'm not, that technical. But I do know that that is available, but it's not available at scale. I what we've done and what we've seen is that a hybrid environment. I mean, this is something that is being adopted globally. I mean, there's a lot of hybrid environments, and everybody's trying to take advantage of aerobatic capabilities, right? So, so to answer your question, yes. Is it proven? Yeah, like Sean said, you probably have some stuff melting before before it's actually as so aerobatic is not going to be as efficient as direct to chip, right? It's just the cooling plate goes exactly on on the GPU, and that's why you get that efficiency. But and immersion cooling, that's even taken a step further. So there are a lot of hybrid environments that are being adopted out there. There are some that are better than others. We've helped develop some very interesting technology that obviously we're not able to talk about under non-disclosure agreement, but I can tell you that the innovation is happening. It's happening now. It's fast and furious. It really goes back to the basis of design, but this is nothing new. I mean, a lot of this stuff has been done before, and so our company having been where they've been in chip fab world, we've been able to back test a lot of these technologies, right? So the solutions are there. You can really today commercially available. You can go up to 650 kilowatts per rack if you must. To get to 1.1, I think that's a different animal, right? So I'm curious to see how that's going to pan out because this is, I guess, Blackwell rack is what they're calling it.
Their new Blackwell.
Yeah. So I mean, I'm learning at the same pace you guys are.
For sure. Well, y'all, that's our hour. Look at that. See what happened? We did it. And see what happens when you're just chatting cool stuff. We made it. We're here. This is so. It's it's been such a good conversation. It's been awesome. Yeah. All right. Well, I'll pretend to be a host. And Gino, if somebody wanted to get a hold of you, how could they do that?
Well, that is not easy because it's my first name, my last name at excite.net. So it's Ginez.toromazote at excite.net. So very long first name and last name. But look me up on LinkedIn. I think probably there are not a lot of Ginezes out in the world out there, especially working at Excite. So
that's great. Awesome. Thanks. And Sean?
Sean.Farney@jll.com. LinkedIn is a good place. And I can't go to all of them anymore. It's impossible, but I try to get it to as many data center conferences and events as possible, and love to meet people live for real at those things and talk shop. So anyone can grab anytime.
Are y'all going to Data Center World? Are y'all going to go?
I've got the best panel at Data Center World.
You do? Oh, very cool.
Building sustainable AI data centers with adaptive reuse. It's real estatey, it's techie, it's got buzzwords.
It's got buzzwords.
I'll get GPU in there too at some point in time. But
I'm an AFCON board member here at the Phoenix chapter, but unfortunately I'm unavailable that week, so I won't be able to make it out to Data Center World. But I really wanted to go, and I'm sorry I'm going to miss you there, Sean, but I'm sure that I'll be able to get that recorded. A lot of the sessions are recorded. I hope yours is recorded. I'll definitely watch it.
Yeah, I got rock stars on my panel, so I'll just
rock stars.
Okay, well, Amy, if you're going, let's meet, or we could do a live version of the show. Wouldn't that be exciting?
Version. Exactly. Well, thanks for coming on, y'all. It's been great. And everybody,
Thanks for having us, Amy. Take care. Have a great week.
All right,
Thanks.
have a good one.
Bye-bye.
Cheers.
Bye. And that's been the show. It's been such a good one. Sean and Gino are really good and very knowledgeable. So that's been a great, great show. This has been a show of the PropTech Council. We are the trade association for the real estate technology industry. So if you want to learn more about us, go to proptechcouncil.com and we will see y'all next week. Have a good one.